Hi there! Today's video is going to be especially interesting because it combines the power of Three.js, a bit of chemistry, and attention to small but important visual details. We're going to create a 3D visualization of an atom, and not just one specific atom, but any element from the periodic table that you choose. Now, I have to say this isn't a perfectly accurate or scalable scientific model. In reality, electrons orbit so far away from the nucleus that if we tried to show it to scale, the atom would look like a tiny dot surrounded by a massive, empty space which simply doesn't work visually. So instead, we're going to focus on clarity, style, and interactivity while keeping the scientific idea in mind. While working on this project, I often caught myself thinking about how most of the universe is actually just empty space, and that thought still amazes me every time. Let's start by sketching out a mini structure for the project. I want the entire design to follow a dark theme, with deep blacks and glowing turquoise accents to give it that clean, futuristic look. At the top of the page, there will be a header with navigation links and a search bar where you can look up any chemical element. The search will be fully dynamic, connected to a JSON file that contains data for all elements, and yes, that file will be available directly on the project page in case you want to check it out or use it yourself. Below the header, you'll find the main feature, the atom visualization. Its protons and neutrons are represented as glowing red and blue spheres, and spinning around them are bright turquoise electrons, following smooth orbits. We'll even add a subtle, almost invisible trail effect to highlight the paths of those electrons as they move. The coolest part? It's all rendered in 3D, which means you can rotate, zoom in, and explore the atom from any angle, making it a perfect fit for a school chemistry project or just a fun way to learn something new. Let's jump into the coding. All the data about the chemical elements is stored in a JSON file, and here's a quick look at its structure so you know what we're working with. We'll build everything inside a single file, keeping things fast and simple. First, we'll quickly set up the HTML skeleton, connect some Google fonts, and prepare the layout. As for the styles, I won't go deep into them right now. I'll just drop them straight into the file so we can focus on the main logic. Alright, next up we'll start writing the core logic, define the main constants, build a function to load the JSON data, and wire up the search input so it responds dynamically. And while we're setting all that up, let's take a short chill moment. Now we're adding a click handler and a function to load our JSON file using fetch. It should work fine. And now we're getting to the core functions that handle rendering and the atom's behavior. Let's code the appearance of protons and neutrons. We'll also need a bit of geometry. Can't do without it. Next, we'll create a function for the electrons and add a glowing effect to their orbits. Then, we'll connect everything inside the main render function. We'll also add a window resize handler. And that's it! Another project completed. Time to celebrate. Let's take a look at the result, how the search works, how the elements are rendered, and what the trajectory looks like. That was our atom visualization, a project from the 10 Labs 10 Habs series. If you enjoy this kind of JavaScript magic, leave a like, fork the repo, and share your improvements. Got a cool project idea? Drop it in the comments. I read them all. All the source code is linked in the description. And hey, don't forget to tell me what project you want to see next. See you in the next video.